Hi everybody, we're on 5.2. This is going to be a really short lesson. We are integrating the natural log function. Last lesson we were deriving it. Hopefully you completed that lesson and you remember that the derivative of the natural log of x is 1 over x, and the derivative of the natural log of u being some function of x, is u primed over u. So if we're going to integrate, then you should be able to tell me what the integral of 1 over x dx is. Well, if the derivative of natural log gives you this, the integral is working backwards. So we should get the natural log of x, absolute value, plus c. And it works just the same for this. If you have a function that is set up with u primed over u du, then you should get the natural log of the absolute value of u plus c. Those are your two integrals. So the whole point of when you're solving these is to make them look like one of these guys. This is what you're going to see most of the time, but 1 over x, that kind of pops up, and that's pretty straightforward. And that will be our first example here. Well, slightly. So if I have the integral of 2 over x dx, right, the 2 can come out, and I'm left with 1 over x dx. Well, that matches that exactly. So it's 2 natural log absolute value of x plus c. That's all you're trying to do, is make it look like one of these two formulas up here. Okay. Obviously, they're not all going to look like that. And you don't have to do this step here. If you saw this and could do it in your head, you know that it's going to go right to there. Number 2. So we have the integral of 1 over 4x minus 1 dx. So I'm going to show you two ways to do this. The first way is u substitution. So we're going to say u is equal to 4x minus 1, because that's pretty much all it can be. So du is going to be 4 dx. So du over 4 is equal to dx. So our new integral, once I sub all this in, this is for du, and that is u. Our new integral becomes the integral 1 over u du over 4, which hopefully you can see. You can pull out a 1/4 integral of 1 over u du. That is the same, u and x are the same thing, essentially. So it matches this one up here. So this is 1/4 natural log absolute value of u plus c. What's our u? 4x minus 1. And that is your integral. Now, there is a slightly faster way to do this once you get good at this, and it is called pattern recognition. It takes a bit of practice, but if you look at this, look at the bottom, and quickly in your head you go, what's the derivative of the bottom? 4, all right? So if I had a 4 up top, it would match this formula. It'd be the derivative of the bottom over, over the bottom, if that makes any sense. So that's, if you see that, you can go right to, it's going to be a natural log function. Now this one doesn't have a 4, but 4 is just a number, it's a constant. So I can make that a 4 as long as I put 1/4 on the outside. And then, because this matches this, it's natural log of whatever the bottom is, u in this case. So this just becomes natural logs of 4x minus 1 plus c. 1/4 has to be there, because you can't just put a 4 in, you have to multiply by 1. So that's why it's 1/4 on the outside. And there is your answer. Now, that'll come with practice. The more you do, the better you get. You'll start to recognize those things. All right. Number 3. So it is the integral 3x squared plus 1 over x cubed plus x dx. Right. Excuse the noise in the background, people. That is my dryer. It's a Friday night. I'm doing laundry and doing calculus. Doesn't get much cooler than this. Okay. All right. So we're looking at this. In your head, if you look at the bottom is a degree 3, the top is degree 2. Well, that looks like some sort of derivative of the bottom on top. So you can check it by doing u substitution. U is x cubed plus x. So du over dx would be 3x squared plus 1. Multiply the dx up top, and it matches perfectly in this case. So our substitution works because this whole thing is du. So the integral becomes integral 1 over u times u. So it's the natural log of absolute value of u plus c, and u is x cubed plus x. And there you go. All right. So, only a couple more examples. Told you this is going to be a short lesson. All right. Number 4. Integral secant squared x over tan x. And this is where your naturally just knowing derivatives will pay off. But you do have a formula sheet, so I encourage you to use it. Although at university next year, they will probably not let you use it. But I know that the derivative of tan is secant squared. So I know if I say u is equal to tan of x, then du is going to be secant squared x dx. So this integral then turns into 1 over u du, which we know is the natural log of u, absolute value of u plus c. So it's natural log of the absolute value of tan of x plus c. All right, now if you do something and it doesn't work out, if it doesn't make a nice integral like this, or u primed over u, and you've probably made a mistake for the ones that we're doing right now, and try subbing in, instead of u here, try subbing in secant squared and see what happens. But in this case, that will not work. All right, number 5, last one for today. So, integral of x plus 1 over x squared plus 2x dx. Okay, again, the bottom is degree 2, the top is degree 1. If you do the bottom quickly in your head, derivative of it, it's 2x plus 2, which doesn't match the top, but that's just by a factor of 2. So I'm going to do the u substitution and try u as the bottom. U is equal to 2x plus 2 dx. I'm going to factor out a 2. Divide that 2 off, and I get this. U over 2 is equal to x plus 1 dx, which is that bit right there. So our new integral is 1 over u du over 2, which means I can pull 1/2 out. I'm left with the integral of 1 over u du, which is 1/2 natural log u plus c, which is 1/2 natural log x squared 2x plus c. And there you go. If you were doing pattern recognition, oops, you could have recognized, like I said, in your head, the derivative of the bottom is 2x plus 2. So if I had something like that, of course you can't just put a 2 there, you'd have to put 1/2 there. And then the top would be 2x plus 2. And then that integral matches u primed over u, which is the natural log of u. So the pattern recognition is just a faster way. It means you don't have to do this, but you've got to be fairly comfortable doing integrals to get to that point. The more you do, the better you get, obviously. So I encourage you to try it, but as long as you're getting the right answer, I don't care if you use substitution if you feel more comfortable with that. That's all I really care about. I want you to get the right answers. So the questions for this are page 334, numbers 1 to 13, odd. In the next little lesson, we'll start to tackle more complex ones. There's a few more trig ones for 5.2, and then we'll be moving on. All right, everybody, good luck.